Thank you all for coming. It's a beautiful day out there to come inside. The climate is cooperating with us today, but as you know, there are all kinds of turbulent events ongoing. I'm Bill Moomaw. I graduated from Williams in 1959, and I taught at Williams for 26 years, the first half of my career, before going to Washington for a while and then transitioning from being a chemist. I was in the chemistry department and director of the Environmental Studies Center here, to working and translating the science I did into policy terms. And I spent the last half of my career at the Fletcher School of Law and Diplomacy at Tufts University, the only chemist on the School of International Relations faculty. Grateful to people who closed their eyes, took a deep breath, and took a chance. It was wonderful. The topic is climate change. And this past academic year at Williams, the organizing theme for speakers and so on was climate change. Many speakers, many events, culminating with this one at graduation. Williams trustees have responded to concerns of the students who 2 years ago began a campaign for Williams to divest from its endowment, fossil fuels, stocks, and so on. The trustees decided instead of, they did, like many trustees of many universities, they didn't want to do that, but unlike many other universities, Harvard and others, they did not stonewall the students. They said, instead of divesting, we're going to invest in infrastructure and activities and so forth that will reduce Williams College's contribution to climate change. Set up a large fund for the next 5 years and made lots of commitments to do things which they are delivering on. Now, the announcement on Thursday by President Trump that the United States was withdrawing from the Paris Climate Agreement is a fairly disruptive move diplomatically, and we're going to have some conversation about that towards the end, but I'd like to postpone that a little bit because there's some other really interesting things that we have to cover here. And let me introduce our panelists. Dr. Gavin Schmidt has an undergraduate degree in mathematics from Oxford University with honors, and has a PhD in applied mathematics at University College London. When he speaks, you will understand where he got his education, I think. He moved rapidly through postdoctoral fellowships at National Oceanographic and Atmospheric Administration, at the National Aeronautics and Space Administration, and then as a research scientist at Columbia University. And then he moved to become, in 2014, when his predecessor, Jim Hansen, stepped down, he moved on to become the director of the highly respected Goddard Institute for Space Studies. And he has done a great deal of work on climate change. He manages the global circulation model, the climate model, which is used by many scientists to test various ideas and compare them to what is being observed in the world. And he's actually the research director of that whole process. He's received 2 major prizes for clearly communicating the complexity of climate change. One, the American Geophysical Union, and one, the EarthSky Science Communicator of the Year Award. So we're very, very privileged to have him here. Let me just add, all of us who work on climate change use the data sets and information that come out of GISS, out of the Institute, almost every day. It is one of the most useful sources of information in the world. Gina McCarthy is a Boston native. When she speaks, you will also recognize that.
I'm wicked clear.
She graduated from the University of Massachusetts, Boston, with a Bachelor of Arts in Social Anthropology, a degree that helped her immensely as administrator of the Environmental Protection Agency. She later attended Tufts University, where she received a Master of Science in Environmental Health Engineering, Planning, and Policy. She served in several cabinet positions in Massachusetts and was an environmental advisor to 5 governors from both parties, Republicans and Democrats, all the way up through Mitt Romney, I believe. Is that right? Then she moved to become the commissioner of Connecticut's Department of Environmental Protection, which is actually when I first met her, and we had some great fun on a couple of panels over the years. And she was central in that role to the successful implementation of the Regional Greenhouse Gas Initiative, which involves 10 northeastern states with a process we have which has systematically reduced the emission from our electric power sector. At the start of President Obama's second term, he tapped her to be the administrator for the Environmental Protection Agency. And in that role, she played a prominent, not only catalytic, but hands-on role in the implementation of, or creating the processes and the rules by which the United States would begin reducing its emissions in agreement with its commitments to the Paris Climate Agreement. So we have today 2 people who really addressed the issue from the science side and from the policy side. And what I hope to do is to share with you the process they go through and their interactions to get us to where we are today. So I'd like to start with you, Gavin, if I might. And if you could just say something about the climate change, how do we know it's changing? How do you and people at NASA and the scientific community generally actually confirm the climate is changing and what's causing it?
It's totally a hoax, you know that.
Right.
I washed my hands and face before I come, I did.
Yeah.
So I work for NASA, and as you were, I think, a little bit too complimentary about my institute, there are about 120 people working on climate models, climate observations, and climate impacts. And it's really important that these things all go together, because we can see in the observations across a whole suite of different kinds of ways to measure what's going on, across a whole suite of different elements of the Earth system, and we see a fingerprint of change that is unmistakable. We can see it in weather station data that goes back to the 19th century. We can see it in ocean data that goes back to the logbooks of the East India Company traversing the Atlantic and the Indian Oceans. We can see the changes that have happened since then. We can see the changes in areas where there is ice. You have a ski hill here, it's not doing so well, unfortunately. But everywhere where there is ice in the world, we are seeing changes. We can go back to old photographs from the 19th century of the national parks, Glacier National Park, Denali, the Himalayas, the Andes, glaciers in Papua New Guinea. I'm not sure did anybody know that there were glaciers in Papua New Guinea? Well, there aren't anymore. Right? So we can see the changes. We can see the changes. We can see the tree line moving poleward. We can see species and plants moving upwards up the hillside. We can quantify these things in many, many, many different independent ways. And we end up with a consilience of evidence. The evidence is that the planet has indeed warmed since the 19th century. Now, it might be you think, well, maybe that doesn't matter. Maybe a few plants moving around, maybe a few glaciers melting. Maybe that doesn't matter. But people, I think, don't really grasp the scale on which the planet has already changed and is destined to change further. And one of the key markers that I find quite useful is to think about the ice ages. So a lot of the landscape here, you're seeing what's left over from the last ice age, right? So that ended about 20,000 years ago. We had glaciers that went from the Arctic Circle down to Prospect Park in Brooklyn and across the whole of the US. Huge glaciers in the in Europe, 120 meters, 400 feet of sea level drop to match the amount of water that was in the ice. The planet's temperature back then was only around 8 to 9 degrees Fahrenheit colder than it was in the 19th century. Okay, and we've gone up now 2 degrees Fahrenheit since then. So we've traversed about a quarter of an ice age in temperature in the other direction, just since the 19th century. And where we're headed is about a whole ice age unit, right, in a kind of business as usual scenario. And the ice age was a very different planet. Ecosystems were different. What were forests were savannas. What were pine forests now was tundra. Everything was changed. Now we, as humans, we just moved around. We didn't have a huge amount of built infrastructure 20,000 years ago that needed to retreat from the rising waters. But we do now. You asked me a very good question. How do we know what's causing this? Right? You know, we've had ice ages, right? Those are relatively natural, they are totally natural climate changes. We've had much larger changes if you go back deeper in geological history. We've had total snowball Earth, right, where there was almost no open water in the oceans, to hothouse conditions, for instance, during the Cretaceous, when we had, you know, the cold-blooded dinosaurs perhaps going up as far north as the Arctic Circle. Those are very, very different climates, and the Earth has gone through many, many different changes. So how do we know what's causing any climate change to occur? Well, we have to think about the fingerprints of change. We have more theories for climate change than there are people in the room, and if this room was filled with climate scientists, we'd have 5 times as many different theories of climate change. But all of these things get tested, right? That's the essence of the science. You make a prediction. I think it's because of dust. I think it's because of volcanoes. I think it's because of the wobbles in the Earth's orbit. Whatever. Make a calculation. Tell me how that would appear in the archives that we have.
Sorry.
Somebody's telling me that somebody has another theory that they want me to check.
Sorry, Donald, we can't talk around.
And so we build tools to allow you to do that. And one of the things that we do is we build these simulation tools, these kind of virtual worlds, where we put together all of the different processes that we think of as being important, how clouds form, how rain comes from the clouds, how the water runs through the soils and into the rivers and back into the ocean and is evaporated again, how the ocean currents get moved around by the winds, how that affects the sea ice, how that affects the heat in the ocean. We build these simulations that include all of the things that we think of as important. Now they're approximations. They're not always perfectly done because, in order to get everything right, we'd have to have a computer as big as the planet. And we don't yet have that. But we have these tools, and we can test these tools, and we can use these tools to test our theories. If you put in a big volcanic eruption, what happens in these simulations? Well, the planet cools. There is a change in the water vapor, and there's a change in the winds, particularly in the northern hemisphere. And then you look at what's happened when there have been big eruptions in the climate record. And we had one in 1991. We had Krakatoa in 1886, Tambora in 1815. We have evidence for what happened, and then we match these things up, and we can see that these models have skill. They do things right for basically the right reason most of the time. And we can do it for lots of other things. That's a fingerprint from volcanoes. We can look at the fingerprint from greenhouse gases. We can look at the fingerprint from the wobbles in the Earth's orbit that actually paced the ice ages I talked about before. We can look at the fingerprint from aerosol pollution. We can look at the fingerprint from ozone depletion, something you worked on. And at each of those points, we can go into the record. We can go into the observations from satellites, from stations, from the oceans. And we can say, oh, okay, yeah, I can see that fingerprint. There's noise in the system, but it comes out of the noise, and you can see this clear signal. And we have seen this clear signal of greenhouse gas warming emerging from the noise since about the 1980s. And since the 1980s, that signal has become stronger and stronger and stronger and stronger, to the point where somebody asks you, that 2 degrees Fahrenheit that we've warmed since the 19th century, what caused that? And the answer is us. Not just a little bit of it, all of it is us. And it's our activities dominated by the burning of fossil fuels. And we've looked at this every which way to Sunday. We've said, okay, well, maybe we've got the sensitivity of the climate wrong. Maybe we've got the history of the records wrong. Maybe the observations, there are uncertainties because, weather stations are curated by people, and people make mistakes, and then they move them around and they don't tell anybody. You factor all of that in, and the answer is still really, really clear. The cause of the climate change in the last century, and particularly the last 50 years, is us. Now that has a very fundamental consequence, because what we're doing has not stopped. What we're doing has in fact accelerated. And so you can make a prediction then that doesn't need a model, but the prediction is more of the same. And we really need to have a better handle on what exactly that's going to be looking like. And so we work on that, and perhaps we could get into that a little bit later. But that's basically, what we do. We look at what's going on, we look for the fingerprints of change, we evaluate those fingerprints of change, and then we make conclusions about what that means for the future.
And if I might add, and all the time, you hold this up to the fundamental principles of physics and chemistry and biology and
right.
atmospheric science, oceanography.
Right. The most fundamental principle is conservation of energy.
Yeah, right.
If you have more energy coming into your system than you have leaving, you're going to warm up. Right? And that's true whether it's a house, whether it's a car, whether it's a planet. Yeah. And that's really the fundamental issue.
I'm sure that if Fourier had lived in 1927 instead of 1827, when he talked about the greenhouse effect, it would be called the hot car effect. Right? That's what
yes.
It would be.
Yes. Well, I think the greenhouse metaphor came from with Tyndall. But maybe Fourier.
All right, you get way too long.
Scientists.
I don't know these people, don't want to know them. I don't know.
Well, they're foreigners. We don't care about them.
Yeah. They wouldn't be allowed here now.
Yeah. So. Now, Gina, let me turn to you. Okay, so Gavin calls you up on the phone or sends you an email or comes to your office and says, climate change is happening and we're causing it. And we're causing it because we're emitting these particular gases that come from burning fossil fuels to a great extent, but other things as well. So how do you, as the president has said, Gina, this ball's in your court. We're going to have to find things that you have regulatory authority of, because the Congress will never legislate what needs to be done. And so I don't know if you want to tell the story about using the Clean Air Act and so on, but just now you have to develop a strategy based on the science and turn it into policy and try to implement it.
Well, that actually is my job, and that is sort of like what happened, except that I think it started a lot before the federal government actually took action, which Bill, because we've known this stuff for a while.
Yes.
And so I've worked at every level of government for 37 years, and so we've been working on issues of climate at the state and the city and the town level. And I think it's important to remember that when you see that the federal government is taking a nap, that we're not all going to be asleep. And so I don't want you to leave here thinking that now that we're not going to be engaged in Paris, apparently as an administration, it doesn't mean that the actions on climate have stopped. In fact, this could be a lightning rod for exactly the opposite, and that's what we're all going to work towards. So let me just say that out at the outset, in case anybody is extraordinarily depressed. I find this invigoratingly depressing. It's different. Okay? Invigoratingly depressing. So Bill, we've been talking about this for a long time. The science has been just getting increasingly certain, and it was certain enough and the dangers were risky enough that action from government was absolutely essential, which is why we started acting at the state level. But the first part of the Obama administration, I actually managed the part of the agency that did the air and climate change work. That was my work. So I've been busy for a very long time because the first thing that I did was watch a Rose Garden ceremony where it was being announced by the president and others that we were going to move forward on the light-duty vehicle rule, which was to reduce the amount of greenhouse gas emissions from vehicles. Because we had the automakers going down the tubes in bankruptcy, the president said, well, I'll bail you out, but you got to like play fair with us and actually develop cars that people want to drive, which happen to be efficient, which happens to reduce greenhouse gases. So I've been working on this for a while, and the first half of his administration, of those 8 years, was really focused on trying to get congressional action. Yeah. If you remember, there was a cap and trade legislation that made its way through the House and lost on the Senate side by 2 votes. Now that would have, I think, made a remarkably good difference in the world had it happened, but it became increasingly apparent that those 2 votes were a gulf that no one would ever get through, and that gulf widened as the opposition to taking action on climate started to gear up in a very concerted way. And I am not talking about the Republican Party, I am talking about the fossil fuel industry realizing that their life could change and not liking it. And that has gotten more extreme over time in terms of the investment of that industry to try to deny what Gavin just said. And so there's been a lot of effort to do that, and more recently to deny the evidence that renewable energy is really good for us and it's saving lots of money, and it actually is in the market the big winner. That's actually trying to be denied, but your pocketbooks won't deny it because it is in fact the case. So when I became administrator, we had worked prior to that happening with the president in a concerted way across the administration to develop a climate action plan. And basically that action plan was a recognition that Congress wasn't going to act, and if that's the case, then let's look at existing authority that Congress gives to the executive branch and see what we have to be able to move this forward. And the thing I loved best, and I love many things about President Obama, but the thing I love best about him was that it was the first time in my life, because I have worked for environmental agencies my whole life, is he recognized, number one, that EPA wasn't an environmental agency, it was a public health agency. And it is. I love the environment, but I only care about it related to how it allows my kids to be healthy. We do public health work. The Clean Air Act is the most substantial public health legislation that's ever been passed. Yep. It has saved millions and millions of lives, and if all goes well, it will continue to do that and more. So we looked back and we sat and we developed a strategy that was an across the administration strategy to say that this was not an environmental problem that was landing on my shoulders. This was a problem that every part of the administration had to engage in, because it happened to be the biggest economic challenge that we were facing, the biggest national security challenge that we were facing. It happened to also be the biggest opportunity we had to actually become stronger as a country, because he knew that whoever led in the race to clean energy was going to lead in the world. And so he saw it as vastly different and needing the entire administration. So he put together a package that was every agency steps up and speaks to their own issue, including the Joint Chiefs of Staff looking at the national security challenge, which, by the way, even today, they think is extraordinary and dangerous. And so we had everybody pulling together. In the first part of the administration, much of the recovery money was spent on developing renewable energy, because it was spent on getting the technology advances that would allow the solutions to be available, because people, I know people, good people. I know a lot of people. None of them will face a problem that has no solution. I've tried that for decades. Climate change is one of those problems. They won't face it, but when you have a solution, they'll readily run towards those solutions. So he spent public dollars on this, which you do to understand the social cost. You do this. So what happened was we had a great plan. It was a lot of strong domestic action. It was advancing work that we did with local and states and tribes on climate adaptation, which is a big piece of the puzzle because we're not going backwards. No. We have to figure out what we do to protect ourselves now. And the third piece was we were doing the domestic action to become the biggest player we could be in the international stage so that we could get an agreement in Paris. That was our focus for 3 years. It was a concerted focus. So we used the authorities we had. Primarily on a regulatory side, we utilized the Clean Air Act because we knew, because when I was in Massachusetts, we sued EPA to go to the Supreme Court and to say that the EPA was forced to consider whether or not carbon pollution, greenhouse gases, were actually endangering public health and welfare because it should be considered a pollutant under the Clean Air Act. That was slam dunk decided. Then we went, when I got there, to do the endangerment finding, which is to look at whether or not, under the Clean Air Act, we are making the case that the science says that people are endangered by greenhouse gases and welfare. We made that case. We moved forward with the light-duty vehicle. I bought a lot of pizza for many people, hours and hours of overtime. And we made the case, and we went to the Supreme Court again, and the Supreme Court actually used language like the science is robust. And the same argument that this president talked about 2 days ago, or two days ago, when he rejected our participation in Paris, that the change is going to be weeny, weeny, teeny, and it really didn't matter. The Supreme Court rejected that because they said that that is not how you measure danger. Everybody has to participate and actually be part of the process. It's like saying to your kids, you got to go out because I'm not going to buy you a new bike, you got to go collect the dollars. And everybody who gives you $5, you say, no, I need 150. Why would I take you $5? The sum is only as good as the parts, babies. So the Supreme Court said that's a ridiculous argument. So we went and re-regulated under the Clean Air Act. And the Clean Air Act has a history of being enormously successful in following the law and the science. And frankly, when Gavin can come and say as directly as he said, we can capture that. And EPA is a science agency. We develop science, but we also listen to the scientists. We work with NASA and NOAA. Yep. That's what we do for a living. And then we translate that into our authorities and responsibilities under the law, and we move forward. So we've regulated cars. We developed the Clean Power Plan, and that is taking science as the underpinnings, but then putting it through a lens of how do we develop steps moving forward that are legally within our authority, but also reasonable enough that you can expect them to get done. Yep. And that we can follow basically the economy, because even though you may have a science that tells you can go leaps and forwards ahead, we live in a democracy, not in a scientocracy. So I take the science and I listen, but it's my job to get people to embrace the solutions and move it forward. So it's all about looking at the clean energy transition, which is moving, underpinning that with regulation so that it provides certainty for a period of time for investment, because as we all know, I don't have the solutions beyond 2025 that's going to get me to 2050 in a reasonable way. So the biggest problem we have today is lack of credibility of the U.S. and lack of commitment in the U.S. is going to mean that investment in the U.S. may not be there, so we don't benefit from the breakthroughs. Mm-hmm. That's what you do by law, is you create a certainty in the market that allows money to be invested, new solutions to be developed, and you start chugging along and chugging along. So I don't want you to think the train's going back to the station. We're chugging along and chugging along. We just may not be benefiting it, but it will chug. because people know there's money to be made. Countries know that that's what's keeping them strong. So we've also moved on methane as well, which is a significant opportunity as well as challenge, and we're moving forward.
That actually withstood a congressional test recently.
It did.
Yes.
It did, actually. We have a lovely little thing called the Congressional Review Act, which has only been used once before.
Yes.
That basically says that within a certain period of time, it's actually, not to bore you, but it's 90 days of congressional time, which to you and I is probably 10 and a half years because they hardly ever actually meet. But they meet an annoyingly number of days.
Yes, they do.
I don't want them to meet more. But anyways, and during that period, they can review it and decide that they don't like the final rule that was passed, and it's only ever been used once,
Yes,
I
before.
think, once before. And so this administration tried to use it a lot. The danger of that is that if you actually, Congress decides against something, you can never do any rule that's substantively similar, and nobody has tested what that means in the courts. Right. So, to make a long story short, the Department of the Interior had a methane rule that had been done within this period of time that Congress looked at, and Congress wanted to overturn it because it was basically requiring that methane be captured, which is a very cost-effective opportunity because it's methane you're trying to actually produce and sell.
It's natural gas.
And so it's methane gas, so they try to capture it, then they sell it. And it's U.S. product, and we're supposed to get money for it because it's federal land. So they basically put a rule that said you have to do that, and Congress did try to overturn that, but it lost. It failed, and which is the first really promising sign that we have that while this administration may want to roll back everything, that there are people in the world, both Democrats and Republicans, who realize how important these things are. And it's pretty significant.
Yeah, good. Let me just, could I get 2 footnotes here?
No.
Oh, come on.
Of course you can.
Can we outvote her 2-1, do you say?
I wouldn't dare.
I wouldn't dare. One is that, for those who don't know, the Clean Air Act was drafted by a Williamstown resident, Tom Jorling, when he was a young lawyer, along with another young lawyer. The two of them, Tom was working for Senator John Sherman Cooper of Kentucky, a Republican, and the other person was working for Senator Ed Muskie, a Democrat, and they crafted the Clean Air Act. And there have been a number of studies that argue that the Clean Air Act is one of the best drafted pieces of legislation in American history.
It's amazing.
It is an amazing piece of legislation because it is, of its clear legal grounds, the structure of it legally is so sound that it actually, and I think it was a 5-4 court case, though, wasn't it, finally, that made the decision, but nevertheless passed muster with the Supreme Court that it could do these kinds of things. That even though climate change was not considered at the time of the act, after all, it was passed in the early 1970s, it still passes muster today because of the way it was structured.
But it does say climate. It says impacts of human health in anything that you put into the air that impacts health, water quality, air quality, or climate.
Yes.
And it's right there, and it was very clear in the statute. And like you said, it was a slam dunk by the time.
Can I make a footnote to your footnote?
Sure.
As you know, federal laws sometimes get updated, which is usually a very good thing if it's done well. In this case, the Clean Air Act was updated in 1990. And basically, the 1990 version looked at whether or not we did everything well and identified some things like toxics rules and others that needed to be updated. But that was actually spearheaded by George H. Bush. So many of the big environmental efforts that have moved forward have been bipartisan in nature, some led by Republicans. This is really a recent history where you see such partisanship in my world. It is not normal.
What's really striking is the original climate agreement. Well, first of all, the ozone protection agreement was in a Republican administration, Gerald Ford. And the climate agreement was in George Herbert Walker Bush. He went to Rio, signed it, brought it back, sent it to the Senate, and just less than 4 months later, it was unanimously ratified. The United States was the 5th nation to ratify. The other 4 were small island nations that were afraid they were going under the waves with sea level rise due to global warming. We were the first. We were the first. When I say this in my classes, the students look at me in utter disbelief that this could be the case. However, it was his son, the second President Bush, who pulled us out of the Kyoto Protocol.
Yeah.
So it's a very mixed story as to how this is all moved through things, through the process. Gavin, if I could come back to you, what do you see as, people are often, the public, and obviously a large number of members of Congress and many people in this administration are skeptical when you as a scientist say, okay, it's like a jigsaw puzzle. We've put all the pieces in place and we can see the whole picture. Right. All right, that's the past to the present. But what about the future? I've often heard, well, they're just playing with their computers. They don't really, you know, what comes out is whatever they put in. It doesn't have any validity. Could you just explain when you say that it could be 5 degrees, an additional 5 or 6 degrees warmer by 2100 than it is today, how do you do that?
Okay, I mean, those are great questions. The first thing to say is things aren't more credible just because they're complicated, right? So these models are complicated. You know, there are about 1 million lines of code that have been developed over 30 or 40 years. And there's more than 20 of these different models around. There's 3 or 4 in the US, there's some in Europe, and in Asia. Everybody wants to have their own because they're checking, right? Because they don't want to just believe something that comes out of somebody's computer from NASA or from NOAA or from somewhere else. The key is demonstrating that where we have big changes in climate in the past, that we understand why those happened and that we can predict the temperature changes that go along with that. So I mentioned the ice ages again. You know, you go back to the last glacial maximum. That's a great example of something where we have tons of evidence for what it was like in terms of temperature, in terms of rainfall patterns, in terms of vegetation. And we have a really good understanding of what that was caused by. It was caused by these wobbles in the Earth's orbit that are happening all the time, but they're happening slowly. So they don't happen on a century to century time scale, but they do happen on, hundreds of thousands of years, tens of thousands of years time scale. And so we can take those parameters, which we know really, really well from Newtonian mechanics, right? There's no ambiguity there. We put them into these climate models, and we say, well, can you produce the climate that we saw 20,000 years ago, 100,000 years ago, 400,000 years ago? And the answer is yes, right? They're not wildly off. They don't they don't produce a climate that oscillates between Venus and Mars. They produce a climate that looks very much like the climate during the last ice age. You go back and you can look at the last time that it was warm, like the Pliocene, like 3 million years ago, which was the last time that we had carbon dioxide levels at the level that we have now. And again, we can say, okay, well, do the models produce about that same level of warmth when you put in what the conditions were then? And the answer is yes. And we keep on testing these things. We go back in time. We find interesting cases. Can the models do this? Can they produce that? And they're not perfect. And a lot of the details at the regional level can be quite uncertain, which is tricky, particularly for things like hydrology, rainfall patterns. That's a real open question that we have in the science. But when it comes to like the amount of ice, the amount of sea level rise, the basic global temperature, these things are pretty well modeled and they're pretty well understood. And so when somebody tells us, well, carbon dioxide, if we burn all of the fossil fuels, if we burn all of the tar shale and the oil sands and the methane hydrates and the oil and the conventional oil and the non-conventional oil and the coal, that's a lot of carbon. And that carbon goes into the atmosphere. What's going to happen? And that's where these numbers come from.
So right? by predicting the past, which you can check,
yes,
you get confidence that you can predict the future. But then you still have to assume, and this is where you get into these, which people have trouble with, scenarios, because
Right.
you know, no one can predict the future in terms of what kind of vehicle I will, or even I'll be driving a vehicle.
That's right. I mean, you know, if you're trying to predict technology for even 30 years in the future,
you're going to miss.
You would have missed cell phones. You would have missed
the internet.
Yeah, I mean, like everything. You'd have got everything wrong. Except H.G. Wells did a really, really good job back in the 19th century. But anyway, but he had a time machine, so that's
he couldn't be on the panel.
Yeah, no, he was busy today. So there is uncertainty in the future. So you have to have a spread that takes into account, you know, the different kinds of planet that we might be dealing. But it's really important to remember that we've been doing this for 30 years, right? The first simulations of future transient climate change were done in the 1980s, right? By my predecessor Jim Hansen, by Suki Manabe at Princeton, and we can go back and we can look at 30 years worth of predictions, and we are spot on, right? What we predicted 30 years ago with much, much worse computers that had less power than your phones, with scenarios that were far less detailed than we can do now, with just like basically the grossest estimates of what was going to happen to carbon dioxide on a business as usual scenario. We nailed it. We nailed the total amount of global warmth. We nailed the patterns of global warmth. We nailed the rate of change of sea level rise. In fact, we underestimated how much the sea level was going to rise. And we did a good job. Now, we don't always do a good job. I mean, you were involved with the ozone situation, right? So we had models back in the 1970s and early 80s that predicted what was going to happen because of ozone depletion. And they said, oh, this is serious. You know, we're going to be losing ozone. And like, oh, look, it's going down. And then, you know, we're going to have issues with skin cancer and all the rest of it. And then in 1984, reports came back from Antarctica that said, yeah, there's a hole in the ozone layer. And
that wasn't in the predictions.
And that was not in the predictions. So people said, what? How can there be a hole in it? And then NASA said, whoa, hold on. We've got a satellite looking at this. And if there had been a hole in the ozone layer, our satellite would have seen it. Right? Because NASA, we're not known for our humbleness. And the odd thing was they went back and they looked at the data that the satellite had brought back. And the hole was so large that the algorithm for processing the data said this cannot possibly be true. And they threw it out. And they threw out the data because it was so dramatically different from what they expected that we missed it. For 2 years, we missed it until
Please don't tell that story.
I'm sorry. I tell that story because I don't want people to think that because we have made good predictions, we are guaranteed to make perfect predictions. And I think that is the worry that we have for the future is not because we know exactly what's going to happen, it's because we don't know exactly what's going to happen. And I think that's a very, very important thing to point out when you're pushing the system so far away from anything that our species has ever, in hundreds of thousands of years, experienced.
But can I just say, one of the challenges that we face as a person that takes the science and translates it into policy and hopefully action, which is what I've done all my life, climate is the most difficult challenge that we have ever faced. The hole in the ozone layer was a shock, but people understand a hole. You know what I mean? They can visualize it.
Yeah.
You can show them, eventually you showed a picture of it.
Yes.
Nobody's denied the hole.
Well, they did for a very long time.
You guys were chit-chatting about it. But when you finally got your act together, we all said, oh, God, there's a hole. And as a result, we had the Montreal Protocol, which was brilliant and now is becoming an effective tool on the climate side.
Right.
Because of the United States, I led the delegation. Yeah, baby. Thank you very much. But the challenge with climate is a dramatic one, and I know that it frustrates people to no end that we're not further along in the curve of recognizing the science. But it's usually difficult to explain climate change. When I listen to you, you make perfect sense to me, Gavin, and you're very good at it. But if you went on the hill, you'd just get killed for what you just said. Seriously.
Yeah, yes.
Because people don't understand how science is done.
True.
They believe that that science comes out with facts, not I have a hypothesis and I can tell you how close I'm predicting.
Right.
That's going to make me think I'm either likely or very likely to be right. You know, and when you say words like very likely, it's translated by a climate deniist as you don't know what you're talking about. It's a crapshoot. Then you go on always, which you just did, frankly, to say, but the science is always evolving. Okay, so I should wait a couple of weeks.
Yeah, yeah.
Maybe I won't have to change fundamentally the energy system that the entire world has chosen and relied on for the past century, right?
Yeah.
And so I think that we really have to be very careful about how we communicate, but also be a little less critical of people who aren't embracing it wholeheartedly, and try a conversation with people. Because one thing that we have learned is that that climate change has become so polarizing that if you're getting together with your family at Thanksgiving, you're not allowed to bring it up. Because there's always going to be somebody in your family, especially if you're a large Irish family like myself, you'll have a number that don't believe in it, you know? So we have to be patient, but we also have to start. I went to and did a fellowship at the Harvard School of Public Health for the very purpose of talking about how science is communicated.
Yeah.
Because saying science is constantly evolving is like if somebody asks me how I'm feeling, and I say I'm fine, but my cells continue to change, so in a couple of seconds I might not be, or I can get hit by a car, so I'm not sure that I'm really fine. Stop saying it's evolving. It's constantly evolving. We're learning all the time. I wouldn't even bring it up. You know what I mean?
Right.
And before you say uncertainty or very likely, just say what you know as a human being. That's science
did
in full.
earlier.
And you did very well.
Right? Did I? I don't think I strayed.
I'm not criticizing you, but but I go up in front of the hill and they start saying, Gina, how many ice ages have there been? And I tell them, I'm not going to go down this road with you.
Yeah.
The science to me is done. If you want to go have John Holdren go one more time and explain it, he can do that. What I'm here is to tell you that the science is good enough, and we are moving on it, and we'll talk about how we're moving on it.
Right.
And it really ticks them off. But if scientists just said, climate change is real, men are causing it, which is why women need to rule the world, my job would be done. My job would just be done. That's what I want to see happen.
Now, this has been such a marvelous demonstration in real time. I can't believe it. I actually heard an interview with a Republican congressman who disputes climate change, who actually said, one of the things about Gina McCarthy is, I don't agree with her on anything, but first she listens, and then she tries to find the means of accomplishing her ends with the least amount of adverse consequences for what I care about. Right?
That's nice.
So I thought that was a huge compliment. Well, this is a great transition to something that I wanted to wrap up with. One of the things this is a story most people don't know, but the first entities to ban chlorofluorocarbons to deplete the ozone layer were the state of Oregon and the state of Vermont. That led DuPont and other companies to come to the Congress and say, we have to have a national rule. And that's when I was working in the Senate and I got to work on that. It was really fascinating because they really didn't want to have 50 different, what can you put in your spray cans? And so that suggests to me that, okay, so if we don't have, and eventually we did get a rule. We passed in the Clean Air Act 1977, banned all chlorofluorocarbons in spray cans. 10 years later, we got the Montreal Protocol. Probably would not have happened if the US were not already there. And by the way, we got the Montreal Protocol during the Ronald Reagan administration. Okay, so you could actually make it work because the business had already come along. So here's my premise. Some people are saying, okay, Donald Trump announced we're pulling out of Paris. screaming, wailing. I mean, the noise level is astounding. As Gina and I were saying beforehand, she's never seen climate change last more than 2 sentences on the evening news before. Suddenly, it's everywhere. Trump says it's not an agreement just to protect Paris. We got to protect cities like Pittsburgh. The mayor of Pittsburgh says we don't want the old economy. We want the new economy, right? So the question is, do you really think we have an opportunity for states, cities, universities, colleges like this one, universities like Tufts, corporations, the private sector? People don't know this, but in Paris, several hundred corporations came together and made commitments for what they would do to address climate change. Not as part of the Paris Agreement, because they don't have a foreign ministry that can go and negotiate. The states and regions led by Jerry Brown of California, with provinces from China, provinces from Brazil, provinces from Canada, states from the United States, states in Germany, Europe, everywhere, making additional commitments. And if you add up all the commitments of states, cities, and corporations that were made in Paris, they exceed the contributions made by the European Union and the United States combined. Do you think this action that's just been taken is going to mobilize that? Is that an opportunity for us? Will it engage people, do you think, to make a difference? And if so, what would you say to graduating seniors today as to what their role might be, even if their federal government, national government isn't doing anything?
So I'm a member of that federal government, so I have to be a little bit careful. I think the key issue is that there is an enormous amount of work to be done, and an enormous amount of enthusiasm to do it. You know, I was in Miami very recently talking to the different universities and the different cities and counties there about how they are thinking about adaptation plans, and how they're thinking about building resilience, and how they're thinking about what happens in an emergency, as well as, you know, how do you make this transition to cleaner energy and to a less polluting form of society. There are very, very complex questions, and they're not purely scientific, right? I mean, you know, how you deal with a city under threat of sea level rise is not a scientific question. It obviously involves science, but the issues are values-based and priorities-based, and those are decisions for politicians and for democracies and for society as a whole to make. And we're not making those decisions in a very joined up way. You know, there is action. The Regional Greenhouse Gas Initiative is a great example. New York City, Plan NYC, and the continuation from Bill de Blasio is a great plan, but they're isolated. Mm-hmm. There are connections, the C40, the C80 cities that link, you know, New York and Burlington and Rio are putting together plans. But a lot of it is, how are we even measuring how well we're doing? Right? What should we be measuring? How do we collate these things? And a lot of that basic work, like just getting the information to allow people to make better decisions and make joined up decisions, so that one decision over here doesn't totally undermine another decision, another plan over there. We're not very good at doing that. And that has to be done with people who have expertise in how to make things work, not necessarily physics and chemistry, and though, you know, obviously chemistry is important. My wife would certainly agree with you on that. But like social sciences, policy making, decision making, we can do a much better job, and we are in many places, but we haven't yet synthesized that. We haven't coalesced that into something that works even nationally, or let alone internationally. But there's an enormous amount of goodwill. There's an enormous amount of people caring, and as the water laps up, the amount of people that care and will need to care is going to increase. And so the work there is perhaps far more important than the work that we do on improving cloud microphysics in climate simulations for 2050.
Gina.
Well, first of all, I know I won't get a chance to say this again, but I wanted to thank Gavin for his work. It's incredible what you do and what you continue to do, and you have tremendous courage. You folks have to understand that one of the reasons why I'm bugging the scientists about how they talk about it is because now they're personally and professionally being asked to defend science that all of us knows is credible. Our process for doing science is being threatened by different legislation in the Hill now that's trying to mess up the peer review process and take away our ability to use data that's the best. And so I can explain that to you, but it's just a very unhealthy atmosphere right now for scientists, especially climate scientists. So Gavin and others have tremendous courage, and I want to thank him for being here and for the work that he does. And that's what baffles me about what's going on now is we all know that science has gotten us to where we are today, to just incredible opportunities available to us and a health quality that we just take for granted because it's so good. But what I want to also mention to you is that while I care about climate, which I do tremendously, you can't separate climate from air quality and water quality and the other things that EPA does for a living. They're all impacted. It's a package deal.
Yes.
So when you hear anybody in this administration say, I'm going back to basics, all I'm going to care about is air and water, just not climate, it is an absolute fraudulent way to actually discuss the issue. And I'm not going back to the 60s again. I lived then. I like today better, okay? So let's make that clear. But I think the president miscalculated in his announcement. I listened to it. We could spend a great deal of time cutting it up, and I could explain to you why everything he said primarily was just not particularly factually correct, let's just put it that way. But I think that it's going to embolden people because I had to do a BBC call yesterday, BBC Radio. And the first thing they asked is, why do people in the United States not understand that about climate change? I said, well, let me just try to knock down that premise because the most recent polling I've seen is that close to 70% not only know it's real, but want leadership at the federal level to take action. They should have thought about that before they stood up and thought that just appealing to a fraction of his base that is focused on coal would be a good strategy for the national government or politically for him. I think it's going to have a tremendous backlash. People are feeling the impacts of climate change. They understand that we have a limited opportunity to actually try to negate a continued change in climate that will make it impossible for us to live sustainably and viably. And so we are close to being there. But we also have to understand that no matter what the president says, executive orders don't take away rules. Only rules take away rules. They have a long way to go before they learn what the law says and what the science says to be able to take away the legacy that the Obama administration left behind. That's clear to me. They have a long way to go. But the other thing that they're underestimating is that they're not going to bring back the technologies of the past when the ones that are with us today are cheaper. Yes. This is the first time in my life I've ever used the phrase, it's the economy, stupid. I've had that thrown in my face. I'm tossing it back at them.
Yes.
Because renewable energy is the future. That's where the jobs are. That's what our kids are studying in school. How many of them here are studying to be able to go back into the coal mines?
No.
I don't think that's really a viable strategy. The better strategy is actually to be honest with folks who are left behind when the economy shifts so that you can make sure that they're not disadvantaged. Not to play into the idea that you can turn the clock back 40 years and not help them to live a reasonable existence today. You know, you've got to, that's what leadership is about. People want federal leadership. That was a mistake. He made a mistake politically for the United States. If he has his eyes on, and you know this better than I, Bill, because this is your expertise in the past 20 years, is if you want to do a trade deal with a country, they'd sort of like to know that you're actually going to stick with the deal.
That's right.
So if trade's a big deal, if national security is his problem, then he did not advance his own interests.
That's right.
So there are so many ways in which that decision is going to embolden Europe and China, who are already looking for a bipartisan agreement to actually fill the gap that the United States is going to leave behind. He's going to preclude us from doing exactly what you said, Gavin, is accountability. We won't be at the table to see if people are actually doing what they say, because it's the U.S. that always had the expertise and accountability, in particular the Environmental Protection Agency. That's what we do for a living. So there are so many ways in which what he did is going to embolden cities and towns and states. I read in the Globe this morning that actually Charlie Baker in Massachusetts says, count me in, one more state. I love it, Republican. God love Charlie Baker. Yeah. We are going to, it is going to embolden people, and John Kerry's talking about we're going to make good on Paris. It doesn't matter.
And
so we are going to get together. Bloomberg's here.
Yeah.
So we're going to be working. And really, what he did was contrary to the advice from hundreds of CEOs,
Yeah.
from investors that manage $7 trillion in assets, wrote to that president and said, don't get out of the Paris Agreement. Whoever buys full-page Wall Street Journal advertisements, if you're a big company worried about the volatility of this president, and you still do it and say, don't get out of Paris, does he think they're not going to change their mind now? No. It's just not happening, folks. It's an opportunity. And the last thing I want to say is if you people are here as parents or grandparents or uncles or aunts of the millennials that are graduating today, I have just spent a lovely 4 months with millennials, realizing that they are not only the most technologically savvy and smartest generation, I think, ever, but they have a sense of social justice and equity that I find just incredibly exciting. I am just so thankful that they are the ones that are going to be pushing. I just feel more positive today than I felt 3 days ago. Because if we had stayed in and not called this question, we might have been sitting on our butts doing nothing, when now we are going to get up and stand up as the United States, and we're going to express our core values, and we're going to do what we have to do. I'm just blown away. I think it's great.
Good.
Let them do that.
We were talking earlier, and I just want to close. Gavin, you had mentioned the statement that Sherry Rowland made about who's the person who, he and Mario Molina from Mexico got the Nobel Prize in chemistry, the only one to be given for an environmental science. And he made an interesting statement. He was actually ostracized. I met him when he testified before Congress, and he came out very strongly that we have to protect the ozone layer. It's going to be disaster. All kinds of bad things will happen. For 10 years, he was not invited by a single university chemistry department to give a seminar. This is a very prominent scientist. Newspapers described him as a California chemist. Right? Okay?
Yeah.
Those of us who, from that era understand what that meant, right? But he, at the end of that period, when everybody else discovered the ozone hole and everything was falling apart, suddenly he was back in favor again, won the Nobel Prize, and became the president of the American Association for the Advancement of Science. And he made a statement, which I'd like to have Gavin share with you.
Yeah, so it's a statement about our dual roles as citizens and scientists. And I think it's very important for people that are in the sciences that we understand that we do have two hats. right? That we make predictions based on our understanding of the science, and we're happy when they come true, but we're citizens, and it matters whether these things happen or not. And Sherwood Rowling encapsulated this very, very well. And he said, what is the use of having created a science that's good enough to give predictions if all we're willing to do is sit around and wait for them to come true? And every day, I'm thinking, I don't want the predictions that we make to come true. And what do? Do we just sit around? I realize I'm sitting right now. But with that one exception, we don't just sit around. We have to talk about what this means. We have to inform the policy that gets made. We have to inform the decisions that are being made at all sorts of different levels. Like the levels that you're making individually as consumers, that you're making as people that live in your town, that you're making as perhaps as donors to this university, that you're making as voters in your state, city, regional, and federal elections. You have power on many, many, many different levels. And even if you're a scientist, you still have that. And we have to use all of those different levers because we don't want the predictions that we make to come true. We really don't. And the actions, of Gina and yourself, and I'm sure the graduating class here will contribute to those better decisions. We need to be making better decisions, and I think we will.
I think the bottom line is you got to get active. Get active talking to your family, because some of the Yale studies I've recently seen are amazing. I mentioned the almost 70%, and almost everybody says that climate change is going to be a big deal, but none of them believe that it's going to impact them, right, because we haven't made it personal. I know from being in politics and in government for a long time, you've got to talk about them. You've got to talk about their children, our public health. It is going to impact directly our public health, our ability to have clean water, our ability to breathe clean air, our ability to be able to have a safe and stable community. So make it personal when you talk to people and try to talk about it. Because if the only time we talk about it is when a president decides to pull out of Paris, then we're in a lot of trouble. You know, it's got to become part of our normal conversation. And get active in your own community. Every community has an opportunity for you to step up. Talk about it with your companies. Get little groups together. Congratulate your state when they do anything good. Mm-hmm. You know, congratulate it. And if there's a town hall where you've got a politician there that's representing you, make sure they represent your interests. And if they don't, tell them they don't. You know, if you think that the Affordable Care Act didn't get changed and go down because of the town halls and people facing their own constituents, you're wrong. That's what turned it. Do it with climate. Demand. Get out there. This is our government. We are the people they represent. You can make all the difference in the world. And somebody has to.
So I just want to, so go forth.
Yes, quick. Oh, no.
Donald, you're on your own. Let's thank our two presenters here.